This looks like a problem that we're looking for an angle here. Specifically, we're looking for angle C. One of the really important things to do when we're trying to do law of sines problems, and I'm going to make sure that this actually works for law of sines. I've got both opposite pairs there. And I'm looking for angle C, and I have the side opposite, so we're in good shape. One of the really important things to do is to make sure that we're on the right track as far as angles that we're solving for. One of the problems with the law of sines is that sine ends up having the same values for some obtuse angles and some acute angles. And if you do some checks at the beginning, that can avoid some trouble later on. One key thing here is that angle B is obtuse. Because of that, angle C has to be acute. Because it has to be acute, I don't need to worry about this. If there were a case where an angle could be obtuse or acute, sometimes I have to work on that. But that's not what's going on in this case. So we've got our setup. So sine of 120 over 13 is equal to sine of angle C over 7. I'm going to multiply both sides by 7 to get rid of that on the right side. And I'm going to get my decimal value here. So we've got 7 times the sine of 120, then divided by 13. That gives us 0.4663 is equal to sine of angle C. Let's do the inverse sine to get that value. So sine inverse or arc sine of 0.4663 is going to give us that angle. So sine inverse 0.4663. We end up at C is equal to 27.794. And just checking, that is an acute angle. We're okay.